A very good afternoon. Good afternoon to one and all. Today, I, Aashish, a third-year undergraduate at the National Institute of Technology, Surat, is going to present my paper entitled An End-to-End Real-Time Face Identification and Attendance System Using Convolutional Neural Networks. The outline of today's presentation will be the introduction, followed by the proposed approach, the graphical user interface, the results, and the conclusion. Now let's start with the introduction. Now we know that attendance and time are very crucial for every institute. Whether it's any school, whether it's any organization, whether it's any college, attendance is very crucial. Now we also seen that the oral attendance system or the traditional attendance system is quite sluggish. It consumes a lot of complex paperwork and it also prone to false attendance. Now with the advancement in technology, we have the biometric attendance system which either uses your fingerprints or your near frontal faces. But as you can see in this image, these are also quite time consuming as we have to stand in the queue and wait for our turn to come. Now with the advancement in machine learning, we have these machine learning based attendance systems which are under research and they are still unable to provide the solutions to the problems like occlusion and the orientation. A paper published in 2013 uses the traditional machine learning approach, but it was unable to provide the solution to these problems. And similarly, a paper published in 2017 uses a deep learning approach, but still that was unable to provide the solution to these problems. Now why ours? Our system is robust against the usual challenges like occlusion, orientation, alignment, and luminescence, or we can say the brightness of the room. Our system was able to get an end-to-end accuracy of 96.02%, which is quite better than the existing real-time deep learning-based systems. Now we have divided our proposed approach into 4 modules: the dataset creation module, the training and testing module, the attendance enactment module, and the attendance manipulation module. Now let's go through them one by one. First, we have this dataset creation module. Now we know that for every deep learning based method, it is of no use unless it is paired with a proper dataset. Now to have a proper dataset for this system, all you need is a 5 to 10 seconds video of every student of the class along with their respective student IDs. Just save them in a folder and rest of the work will be done by this module. Now what this module does, it loads a video, it segments it into frames. Now here the number of frames will be equal to the video FPS into the duration of the video. Here we have taken 10, so it will be video FPS into 10. Now next, this frame will be first padded with the black pixels. Now each padded frame will be passed for face detection over the MTCNN module. Now what this MTCNN module does, it detects the face. This detected face is extracted from the frame. This is resized to 160 cross 160 and it is passed for augmentation. Now in augmentation, what we did, we provide the horizontal shift, vertical shift, we increase the brightness, we reduce the brightness, we blurred the images, we flipped the images, we added 3 types of noises to the dataset. Now as soon as this augmentation is completed, all the images are saved into a folder corresponding to the student ID, and likewise we can create a dataset of all the students of a particular class. And once this whole process is complete, the work of this dataset module is over. Now let's move on to the next module. This is the training and testing module. For training, we have used the pre-trained the inception model, which was previously trained on VCG2 face dataset. We retrained it with our dataset until the accuracy reached above 99%. As soon as the accuracy reached above 99%, we stopped the training, we saved the classifier file to the local disk so that it can be used for further classification. Now as soon as this training is complete, the use of this module is also over. The next module, we have this attendance enactment module. Now what this module does, it takes a CCTV footage and it generates a list corresponding to the names of all the present students. Now how it does, it takes a CCTV clip, it segments it into frames. Now each frame is first pre-processed and then passed over MTCNN for face detection. Now what this MTCNN module will do, it detects all the faces. Now all the detected faces will be extracted from this frame. They will be resized to 160 cross 160 and will be passed over the pre-trained classifier for classification. Now what this classifier does, it classifies each image to its corresponding class based on the maximum score value. Now as soon as this classification is done, we display the output along with the student IDs or the student names. Now as soon as this process is going on, simultaneously we save the list of all the present students so that which can be lately used for attendance marking. So let's move on to the next module, which is the attendance manipulation module. Now what this module does, it takes the list containing the names of all the present students from its previous module. It gets the unique names out of it or the unique student IDs. Simultaneously, it loads a spreadsheet corresponding to the desired subject. It generates a new column corresponding to the desired date, and it marks the attendance based on the list that it has fetched from the previous module. Now as soon as the attendance is over, the spreadsheet is overwritten on the disk, and you can see that the attendance process is complete. It's quite seamless, it's quite simple. Next we have this graphical user interface. Now we know that for every software to be user friendly, it should have a simple and a seamless user interface. Now we have tried to make our user interface as simple as possible and as seamless as it could be. Here you can see the welcome page. It will guide you about the program, about the software. Next we have this home page. Here you will get 5 buttons to create the data set, to train the data set, to test the data set, to run the software, and of course to mark the attendance. Here the next is this dataset creation GUI. Here we have provided several options for user simplicity. User can also allocate the GPU allocation for this software out of in the percentage form. Yeah, we have also provided one more option that user can either create the dataset from the existing video, or user can create a dataset using the live webcam feed. Next we have this training. Here also we have provided an option for GPU allocation. We have also provided an option that user can himself or herself divide the dataset into the training and testing percentages, which will improve the results. Now we have ensured that if any of this field is left empty, or if all of these fields are left empty at anywhere in the GUI, then default values would be assigned so that there is no runtime error. Next we have this attendance enactment module. So here we have option to add the timetable, to update the timetable, to view the timetable, similarly to add the faculty details, to update them and to view them. To mark the attendance, all you need to do is just click on the mark button. The system will load the timetable, it will load the CCD footage, and it will mark the attendance. Now suppose if there is an extra lecture and you want to mark attendance for that. So we have also provided an option for that. Just enter the subject code, just enter the date, just click on the mark button, the attendance will be marked automatically. So here are the results. So here you can see that the last phases, they are very occluded, almost they are occluded 70%. Still they are recognized correctly. The front faces, they are unaligned, they are unoriented. Still they are recognized correctly. And you can notice one more thing, that the brightness of this video is quite not good. Still all the faces in the video are recognized correctly. Our system was able to get an end-to-end accuracy of 96.02%. The recall sensitivity was found to be close to 99.6%. Precision was found to be 96.26%. And the F1 score was found to be 97.9%. We have compared our system with other methods as well, and you can see the results here. So next we have this. We have also ensured that our system is robust against the various environmental factors such as the brightness, the varying hue and saturation, and due to various types of noises. We have tested our system against the high brightness, the low brightness, high hue, high saturation, the Gaussian noise, and the salt and pepper noise. And you can see the results, they are quite appreciable. And here is a sample attendance sheet. There will be institute name, department name, subject name, the student IDs or the student names. There will be a separate section for attendance, and you can do the calculations or the manipulations very simply, just like we have done the average. And the system is quite seamless. And at last, all I can say that is our system is authentic, our system is seamless, our system is robust against the usual challenges of occlusion, orientation, alignment, and luminescence of the room. Our system, when it was tested in practical environment, was able to get an appreciable results, and I can say that it is able to be implemented in various organizations at various institutes to carry out the attendance system. However, our system was quite uncertain for the very distant faces and very low resolution videos, and our future work is currently based on this only. Here are the references, and thank you very much.